Hey guys, welcome to Digital Srini channel on YouTube, and if you haven't already done so, please hit the subscribe button right now. I'm back with another video as part of my Python tips and tricks series, and regular viewers of my channel know that these are the ones that do not fit into my regularly scheduled videos. And whenever I find some topic that I think you guys should know of, I record a video and almost right away I throw it up on my YouTube account. So this video is about pyviz library for interactive network visualization, as you can see from the title. We, assuming all the viewers are humans, we are, when I say we, I'm referring to humans, by the way, we are very visual beings. We like to see things. Especially when it comes to data, we like to see the data presented in a nice structured way so we can infer what the data is trying to convey. And for regular, for example, Pandas based data that we would like to visualize, we typically use matplotlib or Seaborn that makes matplotlib plots a bit more visually appealing. And for interactivity, I usually work with Plotly. So if you have Plotly, Seaborn, and Matplotlib, you are in a very good place. Now, if you ever work with network type of data, don't confuse this with my deep learning networks, although this image looks almost like that, right? I mean, what is a network? I have one node, I have another node, and all these nodes are connected. So think of this as you and your friends. For example, in this case, I put myself at the center of the universe and I have certain friends. And how am I connected? How are my friends connected? So if you would like to map, for example, your LinkedIn connections or Facebook friends to see some patterns, or if you have a very nice novel that you're reading, and there is a central characters and then other characters. How are these characters all connected, and who is the central character? Who is connected to the most ones? Again, I'm just using non-scientific examples for the most part, but you can think of these easily related to many science examples. So if you ever need or find yourself in a situation where you needed to plot these, then pyviz is an amazing library that can that is so easy for you to use. So for the next about 15 minutes or so, I'm going to talk about the basics of pyviz, and to the point where you get some idea of what it does, and if it's useful for you, you can always jump onto the documentation and get more information. So let's just jump into our Colab account and go through a few lines of code and learn about pyviz. Okay, I'm on my Google Colab account. No need for GPU or anything. This is not deep learning. We're just doing some plotting. So first of all, how do you get your pyviz library? It's pretty simple. It's just pip install pyviz. You just need to, I am showing this on my Colab, but to be frank with you, I haven't tested this on my local Spider IDE. Maybe I should have, but I don't see a reason why this does not work. So let's go ahead, and once this is installed, let's go ahead and import our pyviz.network. Go ahead and import network. Why? We'll see that in a minute. Every new connection, every new network, you have to start that class, instantiate that class. So using this network method. So that's the reason why we are importing that. And as you can see right away, all networks must be instantiated as a network class instance. So my net equals to network. You can give any name right there. Obviously, that's just a variable. Let's go ahead and instantiate that. So let's do that. And now what? So now I have a network, a placeholder network. Now I need to add nodes in the network. Nodes is, think of these as these dots that we're trying to add, right? So let's go ahead and add a couple of nodes. And how do you add these nodes? So net.add_node is going to add a node. And we will visualize this in a minute, but just want to go through these in a methodical way. So first of all, I'm going to give the node a value of 1, and this can be anything. You can call it ABCD. It doesn't matter. It's just that a node has a node ID, which is unique to that node, because you have to identify that node with that ID, and you can give a label when you're defining the node. So in this case, the label for that node is Srini, text, and then I'm adding another node without any label, in which case the label is equal to your ID. So when I run this line, the nodes are defined. Now we need to visualize these nodes. How do you visualize these nodes? So first of all, when you when you do your network, right? I mean, we defined our network as net.show is going to save in your local directory a document called nodes.html. You can open this on your local system. You just open your HTML and then you see the nodes on a notebook. The reason I'm doing this on a notebook is so you guys can actually repeat whatever I'm trying to do here on your Google Colab notebook pretty easily. So on the notebook, to open this nodes.html, let's add a couple of lines. How do we visualize that? So to display this from IPython core display, go ahead and import display and HTML. So this allows you to import your HTML file and display it right here in your notebook. So let's go ahead and run this line. You should see two unconnected nodes right there, Srini and node number 2. And you see how this is interactive. This is HTML, this is interactive, I can move. And one thing I should mention is, you see when I'm moving this, there is some sort of a balance right there. It's almost like some sort of a simulation going on. Oh my, Srini is gone right there. So there is some sort of a simulation going on. So there is some physics rules in the back end that it's using, and we can define what type of physics to use. So we'll not get too deep into that, but I'll show you at least the quick basics of what's going on there. Okay, so now that we got that initial idea, now let's move on. So instead of single nodes at a time, because if you have like 500 people connected, you cannot just go one by one. You can actually import that 500 people as a list, define that as a list, and then import that list while defining your nodes. How do you do that? So let's go ahead and start from scratch. So we are again importing our display and HTML, so we can display it right now, right here. And let's define a new network. My new network, net1, is instantiated there, and I am going to provide nodes and labels. Right? These are the two things we need to provide. My nodes is a list of ABCD, and my labels is a list of 3 names. I'm actually using real my childhood friends' names. So Srini, this is myself, and Mike, Imran, and Saeed. So these are the labels. So how do we define the nodes? We have already done that before, right? Add nodes. Sorry, let's go back up. Let me kill this. Let me make sure. There you go. So previously we did add node. This is the difference I wanted to show you. And now we are doing add nodes, because we are adding multiple nodes, so it expects a list. So now our nodes is nothing but our nodes. This is the list, and then my label equal to labels right there. And you can also give different colors to each. I think I have an example down below here, but let's look at this one. So this is how you define your nodes. And go ahead and net1, right? That's my network.show, save it as nodes1.html, and go ahead and display that HTML. So when we do that, you should see I have all my 4 friends right there. Yeah. And you see how things are moving? Again, you can define how spaced you want these to be and how tightly these need to be integrated and all that. So we'll get there in a minute. Okay. Now let's go ahead and assign different colors to each of these individuals. So exactly the same code. In addition to my nodes and labels, I'm just defining colors. And the colors, I'm defining them in hexadecimal code right there. And everything else is the same. So no point in explaining this in any more detail. So exactly the same thing right there. Okay. So there you go. Now, this is just defining the nodes. We need to connect them. Who is connected? Maybe this person is not even my friend. Maybe these are the friends. This guy just lives in the neighborhood. So he's just hanging out, but not related to me at all. So let's go ahead and define that. So how do you define the connections? So this is what we call edges, add edges. And what do we want to add between? So first of all, let's add edges between A and B. What is A and B? A is Srini, B is Mike, C is Imran, and D is Saeed. So I'm just using my node names, IDs right there to define how I want these edges to be connected. So here I'm connected. I'm telling that I'm friends with B. I'm also friends with D, which I think is Imran. Saeed, sorry. So I'm also friends with Saeed right there. And then I'm saving it as a different name, HTML, and I'm displaying it. So now when I plot it, you should see that Imran is just poor guy hanging out in the neighborhood, but I'm connected to Saeed and Mike right here. And by the way, you see when I click on something, all the nodes connected to that are a bit thicker. So if I click right there, they are normal size. And when I click on Saeed, everyone connected to Saeed is going to be, that's highlighted right there. Again, very easy for us to visualize. Okay, let's move on to the next step. What if my friendship with Saeed is a bit stronger than Mike? In this case, I'm like, okay, my friendship with Saeed is equal to my friendship with Mike. Think of this as any other scenario. All I'm trying to do here is add some weight to this character called Saeed. I'm going to say, hey, I'm a bit, he was in my class growing up. So I'm 5 times more bonded with this person than Mike, who I was hanging out in the evening, playing soccer or something. So how do I define that? So to add weight, all you need to do is, all this part is the same. So I'm not going to explain that. So to add weight, when you add edges, just add extra parameter, which is the weight. 1 is basically you're not doing anything, and 5 is 5 times 1, right? So I can be 50, which is a very strong relationship, but I'm going to just add 5 right there and go ahead and plot it, and that line should be 5 times thicker. And this is another way of visualizing your data. So this tells me, okay, these connections are stronger compared to these connections. Okay, and what else? This is another point I would like to mention. There is something called repulsion. When you define a network, you can define repulsion. Now we are getting into the physics part of it. So one thing that you can define is the node distance and the spring length right there. Spring length, think of these as springs, right? There you go. You see, that's a spring. And how does spring work? Again, this is physics, right? And there is some physics that's guiding it. And you can define what type of physics you can use, and we'll do that later on. I'm not getting into physics, by the way. But think of this as springs right there, and this is the node length. And also there is a node distance and spring length. So when I plot that using repulsion, you see how the distance is different, and now you can actually look at the spring length, and the physics is slightly different. Why is this useful? Completely depends upon your specific scenario. Okay, now let's create, all of that is good. Now let's actually take it to the next level. Let's say I have a Pandas data frame that has a whole bunch of data. And how do you work with that? So sticking with my friends logic, let's go ahead, first of all, import my Pandas and NumPy. We are going to capture this into a Pandas data frame. So I define my friends as tuples of Srini and Mike, Srini and Imran, Mustafa, Saeed, Satya, Vamsi, and not just me connected to them. Imran right there is also friends with Mustafa, and Imran is also friends with Mike, and Mustafa is friends with Satya. This is kind of like Facebook now, right? I mean, these guys are all friends. Some of us are mutually friends and so on. So my goal is to show this network. Okay, so let's run this. First of all, define this, and then let's create a Pandas data frame based on this data. I don't have another data frame that I can import and use it right away, so I'm just defining this, and then I'm adding these into 2 columns, friend 1 and friend 2, and we are connected. So let's go ahead and do that. And how does it look like? My friend 1, that's me. Friend 2 is who I am connected to. This is the data frame where we are trying to visualize the relationships. Now let's go down. Let's get all the names, first of all, as a list. And the easiest way to do that is by getting all unique names from each column, right? So first of all, get all the unique names, Srini, Imran, Mustafa, Saeed, and also get the unique names from here, and then combine all of those and create a one unique list of all the friends. The easiest way to do that is using sets. You know that in Python, you have your lists, you have your NumPy array, you have your tuples. Sets, it makes it a bit easy because now we can find what is the intersection between these 2 sets. What is the union? In this case, we want the union because we want all the unique numbers from here, all the unique numbers from here, and then combine them, which is nothing but union. Yeah, so that's exactly what we are trying to do. And just a crash course in case you guys don't know what sets are in Python. I know this is basics, but you never know who's watching this video. So I'm saying my A is 1, 1, 1, 2, 3. So think of 1 as Srini, something else, 4, 5. And then my B is 4, 4, 5, 6, 7, 8, right? Let's go ahead and print A, print B, and then also A union B, and then print U. So this gives you a quick idea of what's happening. So when you do A A, I'm defining this as a set. So it created a set of 1, 2, 3, 4, 5 right there. This is my A. This is my B, 4, 5, 6, 7, 8. When you do A union B, you get 1, 2, 3, 4, 5, 6, 7, 8. So this is exactly what I want to do with my list. That's why I gave a crash course right there. So that's what I'm doing. My people in this network equals to list of set friend 1, friend 2, union. And when you do that, you get all the names. So basically, I'm trying to get all the names in my data frame, all the unique names in my data frame. And this is my universe of friends. Okay, now let's go ahead and visualize the network. This is the easy part. pyviz makes it easy. So first of all, let's define our network as my friends network and add the nodes from people. So it adds 1, 2, 3, 4, 5, 6, 7 nodes right there. So let's go ahead and add them as nodes. And nodes are added, and let's get nodes are added, but we need to create the relationship. For the relationship, I need to know the relationships like right here, Srini versus Mike, Srini and Imran, and so on. For that, I took my data frame and got the values and converted that into a list. So basically, this is the relationship that I'm trying to map. So now I am adding the edges using what? Add the edges using these, Srini and Mike and so on. That's my friends list. And go ahead and show, like save it into HTML and display the HTML. That's it. It's pretty easy. Do this a couple of times. You get a good hang of this if you have a good data set. Okay, there you go. So you see I'm the center of the universe. I'm connected to everyone. In addition to that, some people are connected. For example, if I click on Imran, you see he's connected to Mike, Srini, and Mustafa. Wamsi is connected to myself and Mustafa right there, but Mustafa does not know anything about Mike, and Mustafa does not know anything about Saeed right there. There is no link between these two. The link between these two is via Satya or via me right there. Okay, so that's that. And now I'm taking an example out of the documentation from pyviz. I like this one because this one is about visualizing a Game of Thrones character network. So let's see how this looks like. Again, I promise this is not going to be too long. So here, first of all, let's go ahead and import pretty much the same thing. And it's called Game of Thrones, GOT_network. And this is the network. And by the way, you can define your background colors. You can define your font colors and width and all that. So here, that's exactly what we are doing. And then we are defining, first of all, we are getting the data, but first we are defining the physics. Remember, we talked about physics of this network. So we are going to use something called Barnes Hut, which I believe is default, but even otherwise, you can define it deliberately. It's a model based on inverted gravity model, apparently. And by increasing the mass of a node, you increase its repulsion. Remember the repulsion, we already worked with it. So just define that or explore other options and see how the difference looks like. But the most important part is we are reading this pandas data frame and go ahead and print it. So when I do that, you see this is how the data frame looks like. Yeah, there are many other characters, but the top characters that I'm seeing here. So you see the source and the target and the weight. So the relationship between Amon and Samuel is 31, the strength of the relationship, and that is the weight. And the relationship between Amon and Gren is only 5. And I don't know how this came about. You should probably go to this link and understand more about this data set. But for now, I just want to map these. Okay, so here we have our source, we have our target, and we have our weight. Think of this as friend 1, friend 2, and the strength of our relationship. So that's exactly what we are defining down here. Go ahead and define that, and I'm zipping all of this into here so I can unzip them right there. So for each of these, go ahead and again, these are basic Python operations, so I'm not going to go through those. And now let's go ahead and create a neighbor map. And this is something new. I had to look up the documentation. Basically, when you do get adjacent ADJ, I don't know what ADJ stands for, list, it's a dictionary mapping of node ID to the list of node IDs. So you have a node ID and a list of node IDs. It's a dictionary mapping from each to the other. So we do that, and then for each of those nodes, we are going to go ahead and hover text, add some text to hover. So when you put your mouse over it, then it actually shows that, okay, neighbor neighbors of this character are these people. So that's what it's going to show as a list. Okay, so let's go ahead and show and go ahead and visualize. I know I went through this pretty fast, but please go through this at your own time using a couple of different types of data sets. But you can see how this is working right here. This is what I wanted to show you. How do I scroll down? There you go. So there you go. So now you know that these strong ones are, let me zoom out a bit. This is too zoomed in. Okay. So now if I go back, now you see this probably is one of the central characters. Oh my God, I can't. Let's move this down so it makes it easy to see. This person is connected to so many. I can't even see let's actually look at this other character and look at this character. Not many connections. So Stan is neighbors. So these are all the ones he's connected to, or she. I'm not a big Game of Thrones person, but so there you go. So if you look at this person, is only connected to 2 others. These are all some characters that probably showed up in like not much. So Davos is Shireen's neighbor or connection, and the connection is not as strong. So if you go deep into here, you see the connection between Jaime and Brienne is pretty strong right there. That's a pretty thick line. So that's a lot of weight to this. Anyway, so this is, again, you can move these and you can play with this, but I hope this gives you a very good understanding of what pyviz is designed to work with. And if you ever work with this type of network data, then you know what library to use. Okay, guys, thank you very much, and let's meet in the next tutorial. Until then, please subscribe and hit the like button if you like these videos.